Hi friends, in this video I am going to solve some examples to find oxidation state of metal in central coordination complex. Now I am going to find oxidation state by using 5 tricks we already discussed in the previous video. So take one example, CON tries plus 3. What is this? Ethylene trisethylene diamine cobalt 3 complex. Trisethylene diamine cobalt 3 complex. See here, this complex contains metal and ligand in the coordination sphere. So this ligand is a ethylene diamine is a neutral ligand. Based on the second trick, ethylene diamine is a neutral ligand. If the coordination sphere contains only the neutral ligand, means oxidation state of metal is charge on the coordination sphere. Charge on the coordination sphere. Why? In the coordination sphere, metal and ligand having, but this ligand is a neutral ligand. If based on the second trick, if the complex contain only the neutral ligand means oxidation state of central metal atom is charge on the coordination sphere. So what is the charge on the coordination sphere? Plus 3. So the oxidation state of metal is plus 3. Cobalt is plus 3. Based on the second trick, if the coordination sphere contains only the neutral ligand, means the oxidation state of central metal atom is charge on the coordination sphere. So cobalt oxidation state is plus 3. And then next example, FeCO5 pentacarbonyl, iron pentacarbonyl. See, based on the first trick, all the metal carbonyls, if the complex contain all the metal carbonyls, the oxidation state of metal is 0. Oxidation state of metal is 0. Why? Because cobalt is neutral ligand, so X plus 5 into 0 is equal to 0. So if the complex contains metal carbonyls, the oxidation state of central metal atom is always 0. This is the first trick. See, iron pentacarbonyl, the metal if the complex contain metal carbonyls, the oxidation state of central metal atom is 0. And this example solved by using the second trick, and this example solved by using first trick, what we have already discussed in the previous video. And the next example also, CO2 CO8 dicobalt octacarbonyl. See, this is also carbonyl. All the metal carbonyls, oxidation state of in the metal carbonyls, oxidation state of central metal atom is always 0. Okay, if the complex contain metal carbonyls, oxidation state of metal is 0. Next example, diamine dichlorido platinum 2. See, NH3 twice Cl2. See here, in this complex there is no charge and there is no ionic sphere. So this is a neutral complex. What is the formula of neutral complex based on the tricks? In the third trick, metal oxidation state plus charge of ligands is equal to 0. We don't know the oxidation state of metal, so taken as X plus charge of ligands. 2 ammonia molecules are there, so 2 into NH3 plus 2 chlorines. 2 into chlorine is equal to 0. So X plus ammonia is a neutral ligand, so charge is 0, plus 2 into chlorine charge is -1 is equal to 0. So X is equal to +2. So the oxidation state of platinum is +2. This is the third trick. If the complex is neutral complex, the formula is metal oxidation state plus charge of ligands is equal to 0. We have to find the oxidation state of metal, so taken as X plus charge of ligands, and this is the way to find the oxidation state for neutral complex. This complex is solved by using the third trick what we already discussed. And next example, diamine silver chloride. This is the ionic complex. Why? Because in this complex both coordination sphere and ionic sphere having. So having both ionic sphere and coordination sphere known as ionic complex. What is the ionic complex formula to find oxidation state of central atom? Metal oxidation state plus charge of ligands plus charge of ionic sphere is equal to 0. Metal oxidation state plus charge of ligands plus charge of ionic sphere is equal to 0. So metal oxidation state we don't know, so taken as X plus charge of ligands, 2 ammonia molecules, 2 into ammonia plus charge of ligands having only ammonia molecule, and then ionic sphere having chlorine. So 1 into chlorine is equal to 0. Here X plus ammonia charge 0 plus -1. So chlorine having -1 charge. So X is equal to +1. The charge of silver is +1. Oxidation state of silver is +1. So if the complex is ionic complex, we have to find the oxidation state of central atom by using the fourth trick, and this is the way to find oxidation state of ionic complex. And next, tetraamine dichlorocobalt 3 chloride. Tetraamine dichlorocobalt 3 chloride. See, this is in this complex having cation. If the complex contain cation or ion, the oxidation state, to find the oxidation state of metal by using this formula, metal oxidation state plus charge of ligands is equal to charge on coordination sphere. The charge on coordination sphere in this complex is +1. So X plus charge of ligands, 2 ligands are having, one is ammonia and chlorine, 4 into ammonia plus 2 into chlorine is equal to charge on coordination sphere. What is the charge on coordination sphere? +1. So X plus 4 into 0, ammonia charge 2 into -1 is equal to +1. X is equal to +3. So if the complex contains cation or anion, we have to find oxidation state of central atom by using this formula. So these are the 5 examples to find. We have to find these examples by using 5 tricks. So that 5 tricks are the most important to find oxidation state of central metal atom in coordination complex. I hope you understand. So please like, share and subscribe. Thank you.